No, pop test.
All right. I have done one pop test,
That's terrible.
but it was a test that I gave them a test right before spring break, and then I gave them the exact same test the first day back. All but one of them did better. All right, any questions? Cooper?
We talked about number 12 on the master set last night, about the truck's horn.
Okay. What? So trying to recall, the blowing a horn with a certain,
It had two frequencies, 500 hertz and 495 hertz,
right, what's the beat frequency?
5 hertz.
Okay,
I was more confused for like where it was like, it was going towards the Henway, and then it said something about 330 hertz, and I don't know where that came from.
Thank you. If the truck were going 30 meters per second, heading for a Henway, which is 10 meters away from the oncoming truck, then the 330 hertz sound would sound like what? It's a Doppler effect.
So is 330 hertz just like a new sound for the sake of the problem?
330 is the frequency of the sound at rest. So if the truck's at rest relative to you, you're standing right there, truck's blowing the horn, you hear 330 hertz. When it's coming towards you, it's going to be a higher frequency. Just like when cars pass, you get that, it's a higher frequency coming towards you, it drops going away from you.
I think what Cooper's trying to ask is 330 just another number? Because it starts out saying 500 hertz and 95 hertz.
That is a mistake there. Yeah, apparently I changed the frequencies one place and not another. For part B, assume 330 hertz. If you've already done it, you assume 500 or 495.
I did it, I just assumed that 330 hertz was what we were working with.
Yeah.
So in that problem, would we use the formula that's like the frequency of the observer is equal to the frequency of the what's emitting it, and then like speed of sound minus like the Doppler effect formula?
For part B, you would,
Yes, okay.
yeah, you use Doppler formula.
And then so are we assuming that the observer is standing still in that problem? Like,
Yes.
okay. And then for C, just for clarification, it says something about like V bystander, or was that like the same?
Yeah,
thing as
yeah, the whole problem, just as you're pointing out now, is screwed up. In essence, the 5 hertz beat frequency that the person in the truck would hear would be what into the Henway? The observer on the side of the road. The original intent was that you would take the 500, put that into whatever frequency the observer would hear,
Yep.
take the 495, whatever that,
and do
that-
the beat frequency of those two?
yeah,
Okay.
that was the intent. I'm gonna have to have a whole lot of leeway on how I grade that, because,
So you could use 400, 500, and 495 and subtract the two, that would be right.
well, that would be for part A, but if it's coming towards you, you're not hearing those. So in essence, you could take the beat frequency and just pump that through the Doppler formula.
Use 5.
Yeah.
And it doesn't matter that Henway is like not necessarily a physical thing. Doesn't matter if it's wrong.
The original intent was I was hoping somebody would ask the question in the middle of the test. I assume all of you know the joke. I did have one person fall for it though, years ago. I made some side reference to insert Henway joke here, and the person looked at me and said, and seriously asked, what's a Henway? I was taken aback. All right. Have I answered your questions, Cooper?
Yeah. I was mostly just confused, like, I didn't understand, like, with 330 hertz, like, I didn't
Yeah.
know, like, what the context
I can
was.
very well understand why that would be confusing.
Yeah.
Any other questions? All right. There was a request to go through this test. So let's hit some of the concepts. So, an object moves from point A to point B, experiencing a change in mechanical energy of 10 joules. So, change in energy equals 10 joules. Mechanical energy specifically, what is mechanical energy as opposed to just energy?
Like, motion energy, like kinematic energy?
That would be part of it.
The kinematic plus potential, it's just the energy, right?
It is kinetic plus potential. What is being excluded from mechanical energy?
Thermal?
Thermal is kinetic.
Rest.
Yeah, rest energy is the part that's being ignored here. So we're not worrying about this thing having exploded. If the conservative work done is -4 joules, and then it just asks a series of questions. So, there's more recently I've asked the question of, given this, how many pieces of information you actually have to be given in order to answer all the rest of them? And the answer hopefully is 2, because that's all I've given you. What are the 3 work energy formulas?
Total work is equal to delta K.
Conservative work is equal to negative potential, or negative change in potential. And then non-conservative work is equal to change in energy.
So right off the bat, we're given this and this. So right off the bat, we can figure out those 2 things. And this is work being done on an object. So what's the change in kinetic energy? So we can piece it together here. I know that the total work is equal to the conservative work plus the non-conservative work, because that's what we have. The conservative work is -4 joules, and the non-conservative work is 10 joules. So the total work, or change in kinetic energy, is 6 joules.
Is that NC? WNC?
NC for non-conservative.
And then what's that after the -4J plus?
That's a 10J. The non-conservative work is equal to the change in energy, and it was given that that was 10 joules. And by the way, joule is a capital J, not a lowercase j, as I occasionally see. All right. The change in potential energy. Well, I know the conservative work is -4 joules, so what's the change in potential energy?
4 joules.
Yeah. Conservative work done by the object. A couple people sort of got stumped on this one on the master set. Newton's third law says that forces come in pairs and that each force acts on a different object. So if I have a force doing work on one object, that object must be doing the same magnitude of force, but opposite direction, on the other object. So if I have object A and B, and they're exerting forces on each other, if A applies a force, assuming that they're grappling, applies a force of whatever number, positive F, on B, then B applies a force of negative F on A. They're moving together, they're applying this force over some displacement. So if A exerts, we'll just call this L. So if A does force times displacement, that amount of work on B, then B must be exerting negative FL on A. So the conservative work done by the object is going to be the negative of the work done on it. So the conservative work done by the object would be positive 4J. And then non-conservative work done on the object, well, that's the 10 joules. And total work done on the object, well, we've already answered that one also. It's the same as tangent kinetic energy. And any questions on number one?
The change in kinetic energy, that was the -4 plus 10 joules, or
The
was it?
change in kinetic energy was 6 joules.
So for the answer of this, like, I'm confused on how this is laid out, so I see all the different questions and then A through K, are you asking which answer it is?
It was a multiple choice.
And so when you put, I feel like you put a +4 somewhere, so was that the answer?
So the answer to the change in kinetic energy and the total work of the same thing, that's 6 joules. So that is
H?
H. And H. The change in potential energy was 4 joules. G.
So G.
The conservative work done by the object would be 4 joules. And the non-conservative work done on the object is equal to the change in energy, which is 10 joules.
And so we still need to do the total work done on the object.
The total work done on the object is the same as the change in the kinetic energy of the object. So
So H.
H. Oh, that's right there. Yeah, and I've got the 3 work energy relationships right there. Other questions? All right. 3 objects at rest from the top of an incline are released simultaneously. Object A is a hoop, where they give you the mass and the radius. Then we have the hollow ball and the solid ball. Assuming none of them slip as they roll. Well, if they don't slip, they have to roll or teleport. The moment of inertia. So this comes down to the formulae. So moment of inertia of a hoop. What's the formula? Yep. So this one's just a little bit of plug and chug here. So we've got 5 kilograms. and then 0.3 meters squared. So 0.45, I believe, kilogram meter squared. We have a hollow ball. Assume thin surface. What's the formula?
2/3 that much.
And I gave a mass of 10 kilograms. And a radius of 0.3 meters, I believe. Yep. And we get 0.9 kilogram meter squared. And then we have the solid ball, I believe.
Yeah, but wouldn't that be, did you multiply by 2/3?
I did not. So that'd be 0.6. Nope. Thank you.
Is that a kg times zero?
There, or here,
Yeah, it looks like a L.
that's a kg. Are you criticizing my handwriting?
A little bit, yeah.
Okay. As long as we're clear.
Just being honest. I would never lie to you.
And some of you are not prone to do this, but if I multiply units, put a dot in between, please.
So you don't want a slash?
Not
I
only if
know
you're
I-
dividing. You put a slash if you're dividing, but if I multiply, you put a dot.
So no parentheses around?
You want it as in like this?
Yeah.
It's not technically wrong. I would not take off of that. The issue is, when I was grading the I think it was the master sets, because capital N is not a standard prefix, I did allow a Newton meter like that. However, if you did millinewton, that's a millinewton. That's a meter Newton with a dot in between. So it seems like I took off from somebody who, they wanted to multiply it, they didn't have the dot in between, and the first letter was a normal prefix.
I think it was me,
So-
Dr. Fox.
That was you? Okay.
I think so.
Thank you for setting an example that I could use.
I'm a feather. Got it.
We all are. And moment of inertia for our solid ball.
2/5
So 2/5 times 5 kilograms times 0.6 meters squared. 0.72. So in terms of ranking the moments of inertia, obviously, unless there's careless error in here, solid ball, hollow ball, hoop, in the order of moment of inertia. So the solid ball has the biggest moment of inertia. The hoop has the least. Which one would actually get down to the bottom of the ramp first?
The hoop.
Why?
Because there's angular momentum equals moment of inertia times angular speed.
Okay. Velocity, it's a vector.
Okay, so. And angular momentum is conserved, so if the moment of inertia is greater, I'll just read it.
All right, there's some other factors you're ignoring at the moment. So I got a hoop and a solid, I assume it's a solid ball. In terms of mass, this has more mass to it. Radius is about the same. It's possible the moments of inertia are about the same. Let's see, what are the chances it won't roll off? And what are the chances that it's under 600 grams? Too small. Okay. Let's actually just run through the problem. We'll just take the solid ball. Now, because it is rolling down the ramp, it is going to, we do have to take into account rotational kinetic energy. Some angle theta here. I know that, well, what are the forces acting on the ball?
Wait.
Force.
What kind?
Normal force.
Yeah, there's normal force.
Why is
It's-
normal force that way?
Wait, you said the ball was rolling down?
Ball's rolling down.
Would there be any friction?
There would be. If there were no friction, what would the ball do?
Just
Roll forever.
I think the hand gesture said it, but Miranda, what did you say?
Roll forever.
Oh, no,
Slide.
slide. So there's gotta be some friction in this right here. Because there's no slipping, what kind of friction is this?
Constant, static.
That's what I was going for, static. So let's think, I've got three forces here, two are non-conservative and one is conservative. But let's think about the work being done by the normal force and the friction.